Hi everyone, welcome to a new video. In this video, we'll learn about a method to compute determinants, which is more efficient than the cofactor expansion, especially for large determinants. The general approach will be to simply convert the determinant to a triangular determinant. You may be wondering why triangular determinant? Because these are very easy to compute, as we shall see on this video. But before explaining the method in detail, let us review some properties of the determinant that we'll need on this video. If you want more details about properties of determinants, you can check another video about these properties on the channel. So let's start with this quick review of properties of determinants. First, the determinant of a triangular square matrix is the product of the diagonal elements. What's a triangular matrix? So a triangular matrix is a matrix where all the elements below the diagonal are 0 or all the elements above the diagonal are 0. And in both cases, the determinant will simply be the product of the main diagonal. So if you look at this determinant here, we can see that all the elements below the main diagonal are 0. So in this case, we want to calculate the determinant. We simply multiply the element in the main diagonal. 1 times 1 times 3, that gives us 3. The same thing also apply for the other one. All the elements above the main diagonal are 0. So we can also calculate it in the same way. 1 times 1 times 3 give us 3. And that's the reason actually why we want to convert a determinant to a triangular form, because it makes it direct to calculate the value of the determinant. Next, swapping two rows or columns change the sign of the determinant. So in this example here, for example, I could swap the first two columns, and what this will do is simply to introduce a minus sign. So this determinant is minus the determinant that the first two columns is swapped. So we only introduce a minus sign because we swap the first two columns. I could also, for example, swap these two columns, and what that would do is to introduce another minus sign. So we have already a minus sign times a minus, that gives you plus. So essentially this will be the same as 2, 5, 1, 3, 4, 2, 1, 6, 2. Next property, which is a property that we use frequently when we are reducing a determinant to a triangular form. This property says the following, that if you add or subtract a multiple of a row or a column to another row or a column, that will not change the determinant. So for example, we have this determinant. Let's say that we'll do the following operation. We'll take the second row and we subtract R1 from it, and this become our second row. So what we'll have, R1 remain the same thing, the first row. However, the second row now will subtract R1 from R2. So 6 minus 1 give us 5. 5 minus 2 give us 3. 4 minus 3 give us 1. And the third row remain as is. So according to this property, these two determinants are the same. This operation that we did, we just subtract R1 from R2, will not affect the determinant. Of course, you can do multiple of a row, not necessarily just you're adding or subtracting a row. So for example, we could do something like this. Let's take the third row and we'll add to it twice the second row, and this become our third row. So the first row will not be affected. Second row also will not be affected. However, the third row, now we are modifying the third row. We are adding 2 times the second row to R3. So 5 times 2 give us 10, plus 2 give us 12. 3 times 2 give us 6, plus 1 give us 7, and 2 times 1 give us 2, plus 2 give us 4. So this property saying that the value of this determinant is the same as the original one. This operation does not modify the determinant. Now, a very important point here is that if you are trying to modify a certain row, let's say R2, you can add multiple of another row to it. You can, for example, add 2 times R1 to R2. So you can do things like 2 R1 plus R2, and this become R2. This is fine. Have R3, you add it to R2, and this give us the new value for R2. That's fine. The main thing is that you are adding multiple of another row to that particular row that you are trying to modify. But that row itself, you should not multiply it with anything. So for example, you cannot say something like R3 minus 2R2 and this become our new R2. You are trying to modify R2, but you are multiplying R2 with minus 2. That will change the value of the determinant. The value of the determinant will not be the same. So this is not what this property is saying. You can do R2 minus 2R3 and this become R2. That is fine because I'm subtracting multiple of R3 to R2. But here what you are doing, you are actually also multiplying the row itself with something. So avoid this. Don't multiply the row that you are trying to modify it with anything. Multiply other rows with any multiple you like, that's fine, but not the row itself. Okay, let's see the next property. Next property is saying that if you multiply a row or a column with a constant, the value of the determinant will change by the same constant. What this saying is the following. We have this determinant here. And what we do here, we multiply the first row with 2. So 1 times 2 give us 2, 2 times 2 give us 4, 3 times 2 give us 6. What this property is saying is the following, that this new determinant is twice the original determinant. So this is twice the original one because we get it by multiplying the original one with 2. Another way to think of this is that you can also take a common number as a vector. So if we're starting with this determinant here, we look at the first row, we see that 2 is common. So we can think of this property as that we can take 2 as a common from the first row, so it comes out, and then we divide that row with 2. So 2 by 2 gives 1, 4 by 2 gives 2, 6 by 2 gives 3. Let's say that you want also to take 2 as a common factor from the second column. Okay, so we can also apply this to columns. And let's say the reason for this is that we want to make the first element 1. So I could take that as a common element. So we have 2, this is the original 2 that we have here. And now I'm taking another 2 as a common from the second column. So the first column remains the same. I'm not taking anything out of it. But in the second column, once you take 2 as a common, then 2 by 2 give us 1, and the second element will be 5 over 2, and then the third one, it will be 1 over 2, and then you have 3, 4, 2. These are the main properties that we'll need. So now let's look at some example of reducing this to a triangle. Again, the main idea here is the following, that we have a certain determinant, and we're gonna use these properties to transfer this. So we have, this is the main diagonal. We have some elements here. What we are trying to do is to end up with a determinant where these element now becomes 0. So anything below the main diagonal becomes 0. Of course, we can also do this with the other type of the triangular determinant, which to make all the elements are above the diagonal 0. Both will lead to the same thing, but in this video, we're gonna focus on making all the elements below the diagonal 0. So let's look at our first example. So we're starting with this example. Again, our goal is to make all the elements below the main diagonal equal to 0. In some cases, you may have already some zeros and you don't really need to do a lot of work to get it to a triangular form. In this case, we have a 4 by 4 determinant. So in a 4 by 4, what is the final form that we want when we have a 4 by 4? So in a 4 by 4, you will have some element here, and then below it, 3 zeros. And then in the second column, you'll have some element, we don't know what it is, but below it, 2 zeros. And in the third column, you'll have 1 element, and below it, 0, and then you have some element here. Well, there are some elements here, we don't care about them, but this is what we're trying to get. We want to have the lowest 3 elements in the first column to be 0. The lowest 2 elements in the second column to be 0, and the lowest element in the third column to be 0. If we look at what we have here, we can see actually we have these, but not in the right position. So for example, we have one column here where we have 3 zeros. Okay, but this is not in the first column. Similarly, we have here another column where we have 2 zeros, and then we have here one element where the last element is 0. So we have the correct number of zeros, but not in the right order. So it's a matter now of swapping the columns to put them in the right order. So what we can do is the following. For example, let's bring the third column and make it the first one. This way we'll have 3 zeros in the right position as we need them. So we'll get 6, 0, 0, 0, and then we have 7, 0, 1, 0, and then third one will be 5, 3, 2, 1, and then 9, 2, 0, 0. Remember, the swapping will change the sign. So actually what we'll need to do here to put a minus, because this swap operation add to us a minus. That's what the swap operation do. However, now the second column is not correct. We need the last two elements to be zeros. And 2 zeros we have here. So then we can swap these to get. Again, swapping will introduce a minus. So you have already a minus here, and we're introducing minus, so that give us a plus again. So get 6, 0, 0, 0, and then we are bringing the last column here, and then this remain as is, and the second column now become the last one. So far, the first column and the second column are correct. So the first and the second column is as we want them to be. We only have to fix the third column. So then in the third column, we need to have a 0 in the last position. But here it's not 0. 0 is in the fourth column. Again, we can do a swap operation. Now, a swap operation, again, introduce a minus sign. So we'll have a minus sign here. And then what we get, 6, 0, 0, 0, 9, 2, 0, 0. Now the fourth now becomes the third. This is the swap that we are doing here. And then we have 5, 3, 2, 1. Now we have a triangular determinant, and triangular determinants are easy to compute. You just multiply the main diagonal. So we'll have the minus sign there, and then you have 6 times 2, that gives you 12, times 1 times 1, still 12. So this gives us minus 12. This was an example where we just use a swap operation. Now, in general, you may not be lucky to have zeros, so you may actually need to reduce it in a systemic way. So I'll show you how to do that. So let's go to the next example. Okay, so this is our next example. You can see there are no zeros, so we actually need to introduce 0. Now, always keep in mind what we are trying to do. So remember, the goal is to make all the elements below the main diagonal 0. Another way to think of this is as follows. In column K, you want all the elements below the kth element to be 0. For example, we have here a 5 by 5 determinant. So in column 1, the first element, we don't need to do anything with it. You want all the elements below the first one to be 0. So we want this element, this one, and this one. We need to make them 0. In the second column, you want all the elements below the second element to be 0. So this one here is the second element. You want all the elements below the second one to be 0. In the third column, you want all the elements below the third element to be 0. So this is the third element. You want these to be 0. In the fourth column, you want all the elements below the fourth element to be 0. In the fifth one, you want all the elements below the fifth element to be 0. Of course, there is no element below the fifth element. In other words, always the last column, you will not introduce any 0. You can also think of it as follow. You start with the last column and you move to the left. So in the last column, as we said, there is no 0 to introduce. The one before it, you make the last element 0. The one before, you make the last 2 elements 0. The one before, you make the last 3 elements 0, and so on. So now let's go back to the example. So what is the final form that we should get for the determinant of this example? So we should have some element here and zeros, 2 zeros below it. Then the second element and 0 below it. And then there is something here and there are some elements here. We don't care about them. But the main thing that we have, the last 2 elements are 0 in the first column, and then last element is 0 in the second column. That's what we need. Now, it helps to factor out any number that is common, because that gives you a small numbers, and working with small number is a bit more convenient. Also, I mean, you can proceed without doing this. But in this case, we can see that in the first row that we have 2 as a common. So I can take that out, and then we'll have 1, 2, and 3. 6, 5, 4, 2, 1, 2. Notice that if you multiply 2 with the first row, that will give you the original row. Now to do this, you need to do it in a systematic way. Always start with the first column, introduce 0 in the first column, then move to the second column, introduce 0, then the third column, and so on, depending on the determinant dimension. But always starting with the first column, then second column, and so on. So in the first column, what is our goal? To have 2 zeros, as we see here. Our goal is to have 2 zeros below the first element. How to do this? The strategy is to add multiple of the first row to the rows below it to introduce 0. When you are working with the first column, you use the first row and you add multiple of the first row to row 2 and row 3 to get zeros. And when you move to the second column, you're going to use the second row to introduce 0. So if you are in column K, use row K. So let's stop here to understand the operation that we need to do to introduce 0. So our goal is to make this 6 equal to 0. We want to do this in a systematic way. So what we are trying to do here is that we want to take the second row and we get a new row. So instead of 6, we want to have 0 in the new row. How are we going to do that without modifying the value of the determinant? As you recall from the property, we can always add a multiple of another row to any row without changing the value of the determinant. So what we'll do is we'll add something to R2. So to do this in a systematic way, we look at 6. It's on column 1. So since 6 in column 1, we're going to use the first row. So if an element in column 3, you'll use row 3. If it is in column 2, you're going to use row 2. So we know that we'll have to add multiple of R1. The only thing left is what multiple of R1 we should use. So we need to multiply R1 with something. How are we going to find out the multiple? It's simple. We want to make this 6 0. So you will look at the corresponding element on row 1. The corresponding element in row 1 is 1. We want a multiple of 1 so that when we add it to 6, we'll get 0. We know to make 6 0, we need to add to it minus 6. So somehow this 1, I need to make it minus 6. How am I going to do that? I need to multiply it with minus 6. So then the multiple that we should use will be minus 6. Another way to get this multiple is simply to look at the number that you're trying to make 0, which is 6. You add to it a minus sign, and then you divide it by the corresponding element in row 1, which is 1. So that will give you minus 6. Let's look at another example. Let's say you want to make this 2 0. So since this 2 is in the third row, we're going to modify the third row to a new row where that 2 is 0. So I'm going to modify row 3 to a new row 3 where 2 becomes 0. And how are we going to do that? Again, we need to add a multiple of row 1. Why row 1, not row 2? Because this 2 is in the first column. So we are using R1 to do this in a systematic way. Again, the only thing left is what's the multiple that we should use. So to get the multiple again, we'll look at the element that we're trying to make 0, which is 2, and look at the corresponding element in row 1. Corresponding element in row 1 is 1. To make 2 0, you need to add to it minus 2. So it means this 1, I need to multiply it with something to make it minus 2. And this is obvious because it's 1, I need to multiply it with minus 2. You can also do it as follows. The element that we're trying to make 0 is 2, add to it minus, divided by the corresponding element in row 1, which is 1. So this will give you the multiple that you should use. So this is the way to figure out the operation that you should perform to introduce 0. So now let's go back to the example 2. And then in order to introduce a 0 here, I need to add multiple of the first row. So I need to multiply the first element here, which is 1, with minus 6. If I get minus 6 and 6 give us 0. So the operation that I'm going to do is the following. I'm going to multiply minus 6 times R1 and I'm going to add it to R2 and this give me the new R2. So the first row will not be affected. We are not trying to modify the first row. Actually, we're trying to modify the second and third row because we're trying to introduce zeros in these two rows. So minus 6 times 1 give us minus 6 plus 6 give us 0. As you can see, we are getting 0. If you are not getting 0, mean you did not do the right operation. So you need to look at another multiple. Minus 6 times 2 give us minus 12 plus 5 give us minus 7. Minus 6 times 3 give us minus 18 plus 4 give us minus 14. So we introduce the first 0. Now we need to introduce a 0 in the third row. How to get 0 in the third row? So here we have 2. And in order to cancel this 2, I need to get minus 2 added to it. To get a minus 2, it means I need to multiply the first row with minus 2. So my next operation will be minus 2 times R1 plus R3, and this give me R3. Notice again, R3, the one that I want to modify, will not multiply it with anything, but I'm multiplying the other row. So then minus 2 times 1 give us minus 2 plus 2 give us 0. Then minus 2 times 2 give us minus 4 plus 1 give us minus 3. Minus 2 times 3 give us minus 6 plus 2 give us minus 4. So what we did is we introduced 2 zeros in the first column. Now we need to move to the second column. We'll finish with the first column, move to the second column. What's our goal in the second column? Our goal is to make this element 0. Always keep in mind what you're trying to get. Because we are working with column 2, we'll use row 2 for the elimination. Now we can proceed with this number, but you notice here we have minus 7 and minus 14. I can take minus 7 as common. That will give me a smaller number to work with. If you take minus 7 as common, you will get 2 times minus 7. This is a common from the second row. So our first row remains the same, but the second row becomes 0. Minus 7 divided by minus 7 give us 1. Minus 14 divided by minus 7 give us 2. The third row actually also can take the minus as a comment so that we don't have a minus. So if you take minus 1 out of the third row, we get 0. Taking minus out, we get 3. Taking minus, we get 4. Now let's go back to our goal to make this 0. We are in the second column, so we'll use the second row for the elimination. And in order to get rid of the 3, I need to add to it minus 3. So it means since I'm using the second row, I need to make also the second element here minus 3. Since it's 1, I need to multiply the second row with minus 3. And this will make this 1 minus 3. And I can add it to 3 to get 0. So then you will get 2 times minus 7 minus 1 give us 14 times 1, 2, 3. First row as is, second row remain as is. The operation that we are trying to do is minus 3 times R2. Why I'm having minus 3? Because once you multiply the 1 with minus 3 and you add it to 3, you get 0. And then I'm going to add it to R3, and this becomes the new R3. So minus 3 times 0 is still 0 plus 0 or 0. Minus 3 times 1 give us minus 3 plus 3 give us 0. Minus 3 times 2 give us minus 6 plus 4 give us minus 2. Now this is a triangular matrix. All the elements below the diagonal are 0, so it's easy to evaluate this one. So get the 14 times. This can be evaluating by multiplying the element in the diagonal. So you'll have 1 times minus 2. And this gives us minus 28. So this is in general the strategy. You start with the first column, you make all the elements below the first element 0. Then you move to the second column, you make all the elements below the second element in the second column 0, and so on. For the elimination, if you are in column 1, you're going to use row 1. If you are in column 2, you're going to use row 2. Let's illustrate again this with another example. Let's take 4 by 4 this time to show you the strategy. So this is another example to illustrate. This is a 4 by 4. Again, keep in mind the goal that you're trying to achieve. So what you're trying to get is that after all, what you want to get is in the first column, you have some element and below it 3 zeros. In the second column, you'll have something, then another element, and the last 2 elements should be 0. In the third column, you'll have 3 elements and the last one is 0. In the last column, we don't care what are the elements. In the last one, we don't really need to introduce any zeros. So we're trying to introduce 3 zeros in the first column, 2 zeros in the second, and 1 zero. Looking at this, again, it's helpful to factor out any common value because that gives you a smaller number to work with. So we can see the first row that we have 5 as a common. I can take it out. Then get 5 divided by 5 get 1, 10 by 5 give you 2, 5 by 5 give you 1, minus 15 by 5 give you minus 3. And then the other rows. So you may notice here that we have a 0. And you might choose to also swap the first two columns because that give you 1 0 in the first column. We can do that. That's also something that you may want to do. But let me show you that in case you did not do that, you still the procedure will work and you will get the correct triangular form. Just follow the steps systematically. So always starting with column 1, then column 2, then 3. So column 1, we're trying to introduce 3 zeros. Since we're on column 1, we'll be using first row to introduce the zeros. So let's see how to do that. So 5, the first row will not change. We'll be using it to introduce zeros in the other rows, but itself it will not change. Looking at the first element here, this is where we're trying to introduce 0. So this is 3. In order to cancel 3, I need minus 3. So it means I need to multiply. Here I have 1. So I need to multiply 1 with minus 3. So then our first operation will be minus 3 R1 plus R2. That gives us R2. So minus 3 times 1 give you minus 3. And you add it to 3, get 0. Minus 3 times 2 give us minus 6. You add it to 0, give you minus 6. Minus 3 times 1, it give you minus 3, plus 1 give you minus 2. Minus 3 times minus 3 give you 9, plus 2 give you 11. Then we need to move to the next row, and we are trying to introduce 0 here. So this is easy because the two elements are equal in value. What we need is just to have a minus sign for the first row. So we can use minus R1 plus R3, and this becomes the new R3. Minus 1 times 1 give you minus 1, plus 1 give you 0. Minus 1 times 2 give you minus 2, plus 2 give you 0. Minus 1 times 1 give you minus 1, plus 4 give you 3. Minus 1 times minus 3 give you 3, plus 6 give you 9. Now we just need to introduce a 0 here. And in order to cancel this 2, we need to get minus 2. And to get minus 2, it means I need to multiply the 1 with minus 2. So the next operation will be minus 2 R1 plus R4, and this becomes the new R4. Minus 2 times 1 give you minus 2, plus 2 give us 0. Minus 2 times 2 give us minus 4, plus 1 give us minus 3. Minus 2 times 1 give us minus 2, plus 6 give us 4. Minus 2 times minus 3 give us 6, plus 3 give us 9. So we already have fixed the first column. We have 3 zeros in the first column. The last 3 elements are 0. Now we need to move to the second column. What is our goal in the second column? We want the last 2 elements in column 2 to be 0. Fortunately, during the process, when we are introducing zeros in the first column, also we introduce a 0 here. So we already have 1 0. So the only thing that we need now to do is to introduce a 0 here. So to cancel minus 3, I need a 3. And remember, we are using, because we're on the second column, we're going to use the second row. And you have here the element above minus 3 on second row is minus 6. I need to make this minus 6 to be 3 so that it cancels 3. How to make minus 6 3? You need to multiply it with minus half. So here we'll have 5, 1, 2, 1, minus 3, 0, minus 6, minus 2, 11. The third row will not be modified, so already have 0, so it remains as is. So now we need just to modify the last row. Again, to make the minus 6 to be 3, we just multiply with minus half. So it will be minus half times R2 plus R4, and this becomes the new R4. So minus half times 0 is 0, plus 0 is 0. Minus half times minus 6 give us 3. 3 plus minus 3 give us 0. Minus half times minus 2 give us 1, plus 4 give us 5. Minus half times 11, that give us minus 11 over 2, plus 9. So this give us 7 over 2. Remember, we're having something like this, 9 minus 11 over 2. So this give you 2. Here 18 minus 11. 18 minus 11 is 7. That's how we get 7/2. Now we are almost there. We just need to have a 0 here. In the third column, we need to have the last element to be 0. Once we do that, we have a triangular matrix. So before we proceed further, we can see in the third row, we have 3 as a comment. So again, that can simplify our job by introducing small numbers. So if you have 5, I can take 3 as a comment from the third row. So what we'll have is the following. The first row remain as is. Second row remain as is. And the third row now we took 3 as a comment. So 0 by 3 is 0, 0 by 3 is 0, 3 by 3 is 1, 9 by 3 is 3. And then we have 0, 0, 5, 7/2. So we go to our task. We are trying to make this 0. Since we are now working the third column, we're going to use the third row for elimination. So to eliminate this 5, we look at the number on the same column but in row 3, because row 3 is the one that is used for elimination. So we'll see we have 1. Question is how to make 1 cancel 5. We need to multiply the 1 with -5. It becomes -5 plus 5 give you 0. So the operation that we'll do is -5 times R3 plus R4. This gives us the new value for R4. So 5 times 3 is 15. So we have the first row as is, second row as is, and then the third also row as is. Now the last one we need to calculate. So -5 times 0 give us 0 plus 0 give us 0. -5 times 0 is 0 plus 0 give us 0. -5 times 1 give us -5 plus 5 give us 0. -5 times 3 give us -15. -15 plus 7/2, that give you -23/2. It's like this, -15 plus 7/2. We have 2 as a comment. 2 times 15 give us -30 plus 7. -30 plus 7 give you -23/2. That's how we get -23/2. Now we have a nice triangular determinant. We have the last 3 elements are 0 in the first column, the last 2 elements are 0 in the second column, and the last element is 0 in the third column. Calculating this is straightforward. We just multiply the element in the diagonal. So we have this 15 times the elements in the diagonal are 1 times -6 times 1 times -23/2. If you multiply this out, you will get 1035. So that's it for this video. If you find this video useful, please give it a like and also consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.